Suppose we have a n by n matrix A, then the determinant of this matrix can be written as where we are summing all of these indices, and this symbol here is called Levi-Civita symbol. It's a completely anti-symmetric tensor, which means that if we interchange any of its two indices, any of its two neighboring indices, the sign of this tensor is changed. If n is equal to 2, for example, then epsilon 1 1 and epsilon 1 2 epsilon 2 2 are both equal to 0, because epsilon is a completely anti-symmetric tensor. So if any of its two indices are equal, then it is equal to 0, and epsilon 1 2 is equal to 1, and epsilon 2 1 equal to minus 1. So in this case, if we have a matrix A11, A12, A21, A22, and its determinant according to this sum here will be equal to epsilon 1 2 1 2 plus epsilon 2 1 2 1, which will be equal to A11 A22 minus A12 A21, which is exactly what we will get if we use the if you calculate the determinant by expanding, for example, by this first row, A11 into A22 minus A12 into A21. As one more example, let us consider a three-dimensional matrix. So when n is equal to 3, then epsilon 1 2 3 is equal to 1, and any of the odd permutations of 1 2 3 will give minus 1, and all even permutations of 1 2 3 will give plus 1. So we will have epsilon 1 3 2, which is obtained from 1 2 3 by interchanging 2 and 3. So it will be equal to minus 1, because it involves only one single interchange. Similarly, we have epsilon 2 1 3 equals minus 1, because it also involves odd number of interchanges. If we interchange 2 and 1, we get 2 1 3, so only one interchange is involved, so we get minus 1. Epsilon 2 3 1 involves two interchanges, means even number of interchanges, so it will be equal to plus 1, and epsilon 3 1 2 will again be plus 1, and epsilon 3 2 1 will be equal to minus 1, and all other values of this Levi-Civita tensor, in which any two indices are equal will be equal to 0. So now if we have a 3 by 3 matrix, A11, A12, A13, A22, A21, 22 and 23, A31, 32, 33, then according to this sum here, the determinant will be epsilon 1, 2, 3, A11, A22, A33 plus epsilon 1, 3, 2, A1, 3, 2 plus epsilon 2, 1, 3 2, 1, 3 plus epsilon 2, 3, 1 2, 3, 1 plus epsilon 3, 1, 2 3, 1, 2 plus epsilon 3, 2, 1 3, 2, 1. Now if we replace these symbols by their values, for example epsilon 1, 2, 3 is 1, epsilon 1, 3, 2 is minus 1, epsilon 2, 1, 3 is minus 1, and epsilon 2, 3, 1 is plus 1, epsilon 3, 1, 2 is also plus 1, and epsilon 3, 2, 1 is minus 1. Then the expression that we get is here we have a plus sign. This expression is simply the determinant of this matrix here. Now this we have here considered only two examples of a 2 by 2 matrix and a 3 by 3 matrix, but this is a general formula. This formula holds for any matrix of order n by n.